Assalamu alaikum. Ali, can you hear me?
Ji walaikum assalam, I can hear you.
Today we are doing, because now it's nearly over for paper 2. So today I'm doing some work on Kirchoff, the DC circuit chapter. In that chapter of DC circuit, there are two main topics. One is Kirchoff rules and second is a potential divider. I'm selecting November 14, 236. A wire has length 100 centimeter and diameter 0.38. The metal of the wire has resistivity. This show that the resistance of the wire is 4 ohm. Observe this. Let me know once you get the answer.
It's coming as 1.2 into 10 power minus 3. Okay, it says diameter, that's why I think it's coming wrong. Because we need to find the area, I think, pi r square.
This is a mistake. Actually, this is diameter. Good. Now, this is the formula for area. And we should first find the area.
Area is 1.13 into 10 power minus 7.
The ends B and D of the wire in A are connected to a cell X as shown. There's a wire BD. The cell X has electromotive force 2 volt and internal resistance 1 ohm. A cell Y of EMF 1.5 volt and internal resistance 0.5 ohm is connected to the wire at B. Now it's visible that it's a potentiometer, potential divider. It's a potential divider circuit. The point C is distance L from point B. The current in cell Y is 0. It means it is on the null position.
What was the formula for the potential divider? I kind of forgot.
Actually, the simple ratio method, no particular formula, but it's like a ratio method. You have to apply the ratio. Voltage and resistance, they occur in a ratio. So the slider is at a position, it's a metal wire, and the slider is presently at position C. The point C, calculate the current in cell X.
But by doing V is equal to IR, we will get like 2 only as the answer.
V is equal to IR. We have a resistance 0.5 and we have a resistance of 1 ohm, and we can look at the range. He says
No,
current in
on the
cell
cell,
X.
it only shows like 1 ohm resistor. So we will only take
Right, because he's talking about cell X. So V is equal to IR. Acha, this is right. Okay, 2 and 1. The potential difference across the wire BD. There is a problem coming. I think you told me, but I didn't correct it. This answer was coming 4 or not? This one, the first part, because he said you have to show it coming to 4.
Yes, it was coming to 4 with the area.
Okay. The resistance of the wire is 4. What wire? Achha, this is the same wire which is connected now to the cell. So now we have to consider this calculation again because we didn't consider the wire. The current in the cell will be going through the cell and it will be going through the it will be going through The total resistance, the internal is I and the external is 5. So the voltage is 2. The potential difference across the wire BD. We know the resistance of the wire and we have the current now. So current is 0.4 and the resistance of the wire is 4. This is the voltage, the total voltage across the wire BD. PD across BC. Now, how much the PD would be across BC?
2 minus 1.6.
No, remember that the cell is at null position. Cell is at 0 position. The current in cell Y is 0. So this is the voltage of the cell and he's asking the voltage across this. So what voltage should I put here to get the overall voltage 0?
1.5.
Yes, this is the tricky part of the question. This is the concept of potentiometer, that the two voltages should be equal to 0. The two voltages should be equal to 0. So the voltage across that point is 0. He's asking for the length L. What is the length of the wire BD? We have the length. If we go back and we look at the length of the length of the wire was 100 centimeter. Is it 100 centimeter here also? BD. It looks that the wire has a length 100 centimeter and we need to find this length. We need to find this length and we have already calculated that total voltage coming here is 1.6 volt. And on this length, it is 1.5 volt. So we can put a ratio to find the answer. How I can put the ratio?
On 1.6 volt, it would be 100 centimeters, so 1.5. It is coming as 93.75.
The connection at C is moved so that length is increased. Explain why the EMF of the cell Y is less than its terminal PD, because you can see there is some resistance internal resistance is present. Now he says that he is moving the slider. He is moving the slider. The connection at C is moved so that L is increased. Explain why the EMF of the cell is less than its terminal PD. So it can be seen that this cell has some internal resistance. The cell has some internal resistance. So its terminal PD cannot be equal. Its terminal PD cannot be equal to the battery EMF. June 15, 225, the figure sketch the temperature characteristics of a thermistor.
This was the one in which, like, when the temperature increases, the resistance dropped.
Yes, very good. The temperature increases and resistance decreases, and it's a curve. This is a sketch of a thermistor. A potential divider circuit is shown. The battery of EMF 12 volt and negligible internal resistance is connected in series with resistor X and Y. X and Y. And thermistor Z, the resistance of Y is 15 kilo ohm and the resistance of Z at a particular temperature is 3 kilo ohm. It is Z. Achha, okay. The potential difference across Y is 8 volt. Explain why the power transform in the battery equals the power transform in X, Y, and Z. Because examiner already says the internal resistance is negligible. Calculate the current in the circuit. battery is 12 volt and the resistance of Y is 15, resistance of Z is 3. Okay, resistance of Y is 15, resistance of Z is 3. Acha, the resistance of X is not given. Resistance voltage across Y is 8 ohm. But what is the resistance of X?
Will we have to use the ratio of this potential
I'm
difference?
also thinking the same thing because he has given me the voltage across Y. Because it's a series circuit, so I can use the idea of series. So 8 volt and 15 kilo ohm.
It is 5.33 into 10 power minus 4.
5 point.
33 into 10 power minus 4.
Calculate the resistance of X. Now we have the current 5.33. We have the current and we have the resistance we need to find for that. He says calculate the resistance of X.
So Z will have 1.6 volts across it to 2.4 volts.
That's a good idea. But what I was thinking, if I add all of them, I will get the effective resistance and I can put 12 volt of the circuit. I mean, if I use V is equal to IR,
It is 22,514.
acha.
The total distance which I calculated.
You mean how you got total resistance? Because we need to find
I said like 12 volt is equal to the voltage and the current is the above value. So
okay,
I
then
just
you have now you have to subtract from it. You're saying that.
yes.
Okay, it's the same thing. Perfect.
I tried both ways. I'm getting the same answer, like 4502.
Can you repeat 44.5?
4502.
4502.
Yes.
The temperature of Z is increased. State and explain the effect on the potential difference across Z. The temperature of Z is increased. Explain the effect. It's a thermistor. So if temperature increased, resistance will decrease. It's a thermistor. So what about in a series circuit? So voltage will decrease. Now, this is our next question. A uniform resistance wire AB has length 50 and diameter 0.36. The resistivity of the metal is this. Is a resistance.
It is coming as 2.5 ohm.
Acha, final answer.
Yes.
The wire AB is connected in series with a power supply E and a resistor R as shown in the figure. There is a wire, the wire is AB with a power supply E and a resistor R is shown. Where is resistor R? Okay. An EMF of E is 6 volt and its internal resistance is negligible. the resistance of R is 2.5 ohm. The second uniform wire CD is connected across the terminals of E, and it has length 100 centimeter, diameter this, and is made of the same metal, as the wire AB. The current supplied by E So we have to see that we have a 2.5. There is no internal resistance. What about wire AB? Wire AB resistance is also 2.5. No. Achha. So there are two wires. Wire resistance of the wire AB is also 2.5.
So we will add 2.5 with 2.5.
It looks to be the same.
Okay, it says of R and it first said AB.
Huh? Sorry.
The resistance it says is R of 2.5. And
He's
also for
resistance R is 2.5. Actually, we need the total resistance of the circuit. What is the resistance of CD?
so we'll have to find the resistance of CDs. The row will be the same and L over A will use.
Achha. You're right. Five point 10 power minus 7.
It is coming as 20 ohm.
Yes, 20 ohm. Good. So there is a resistance of AB and 2.5. First, I go for AB, that will be
It is coming as 6/4, 1.5 amperes.
now what was the resistance coming? The effective resistance?
4 ohm.
The power transformed in wire AB. This is wire AB. We have the resistance, but the problem is current. Actually, we know the current of the whole circuit, but we do not know the voltage. But I was thinking that the battery is of 6 volt. Okay. If the battery is of 6 volt, this is also 2.5, right? So it will get 3 volt and it will also get 3 volt. Is this right? They both will get 3 volt.
Yes, but won't the current also go down because it divides in parallel?
Because no, you're right perfectly. I do not know the current. Current will definitely divide, but I was thinking that we need to find the power. So we have the voltage and we have the resistance. So we can use that idea.
Voltage will be the same across the whole
No, voltage is divided, na? 3 volt, 3
circuit.
volt. Acha, that one, because in parallel voltage is the same, na? This
So they
loop
are equal, like in ratio.
gets
So they're
6
equal.
volt, and this loop will also get 6 volt. They both will get 6 volt. Inside it is divided in 3, 3.
It is
Let me
coming
know.
as 3.6.
Okay. The potential difference between the midpoint M of wire AB and the midpoint N of the wire CD. We need to find the potential difference between B and N. So let's first, I'm writing an error because it's M, it's not B. Sorry. So if it is 3 volt across AB, can I halve it and make it 1.5 on AM?
Yes, because it's the same wire.
Hmm. CD. Now, what was the voltage CD where I got it? Did I get VCD? It should be 16, right? Because there is no other wire to share. So if it is taken as full 6, so this is November 16. State Kirchoff's second law. So what was the Kirchoff's second law? It's a memory game.
That the EMF is equal to the sum of the PD.
Across a closed loop, the sum of voltages is equal to the sum of the voltages is equal to the algebraic sum of the EMFs. A battery is connected in parallel with 2 lamps A and B as shown. A battery is connected in parallel with 2 lamps A and B. The battery has EMF 6.8 volt and internal resistance R. IV characteristic of lamp A and B are shown. There are 2 graphs. The PD across the battery terminal, the PD across the battery terminals is 6 volt. Acha, some voltage is lost across the internal resistance. The current in the battery is 0.4. So I can take 6 and then I can get the current. The 2 currents would be divided. The terminal PD is 6.
This is 0.25 plus 0.15, I think almost like that.
0.2, I think 0.26, the above one.
Yes, like adding to 0.4, I think they are. Because I don't think the Ohm's law can be used because it's not a straight line.
But we just need to find the total current. So I'm reading from the graph. So if we but we need to find actually 0.4. Calculate the internal resistance of the battery. Now we know the current, so we should find the EMF. This is a formula, but I don't have the resistance, so we should use second law. The resistance is coming to ohm. Determine the ratio resistance of lamp A to resistance of lamp B. How I can get the ratio? If I go for Ohm's law, in parallel, voltage is the same. But how I can get the current? I have the current, sorry, 0.14 and 0.26. So I can put the current 0.26 and 0.14.
It is 1.86.
Determine the total power produced by the battery. The total current was, how much was total? 0.4. Calculate this.
It is coming as 2.72.
The efficiency of the battery in the circuit. output power terminal PD was 6.
It is 88.24.
$88.
0.24%.
Right. 80. Then I should write 88. So we did this question. We revised some Kirchoff questions today and potential divider. Potential divider is also a very challenging topic, but many people neglect it because Kirchoff is so much known and so much discussed. Even though many teachers think that potential divider, potentiometer are actually more difficult questions. So we'll do, I have already posted the revision handout, so you should revise that. And we will do, inshallah, in our tomorrow class now. Allah Hafiz.
Allah Hafiz.